Hello friends, today I will discuss the numerical problems on the dot rules. So before I discuss the numerical problems, so let me consider the dot rules. So there are two coupling coils. This is one set, this is another set. Dot rule 1 says if the current enters the dots or leaves the dots in both the coils, then the mutual inductance will get the same sign as that of the self-inductance. Then second rule says that if the current enters the dot in one coil whereas the current leaves in the other coil at the dot, then the mutual inductance will get the negative opposite sign as that of the self inductance. So you can see here current enters the dot, whereas in the second coil current flows through the coil then leaves the dot. Similarly here current flows through the coil and then leaves the dot. Similarly here current enters the dot then goes through the coil. Whereas in first rule current enters the coil dot here. Similarly here also current enters the dot then goes through the coil. Similarly here current enters the coil and here also current enters the coil and but leaves the dot here. Similarly here current leaves the dot here. So let me consider a problem. Write the inductance matrix for the following circuit. So here let me represent the sum of the terms and its meaning. So L11 means it is the self-inductance of the coil 1. L12 means it is the mutual inductance between coil 1 and coil 2. L13 means it is the mutual inductance between coil 1 and coil 3. LT1 means it is the mutual inductance between coil 2 and coil 1. L22 means it is self-inductance of coil 2. L23 means it is the mutual inductance between coil 2 and coil 3. And L31 means it is the mutual inductance between coil 3 and coil 1. And L32 means it is the mutual inductance between coil 3 and coil 2. And L33 means it is the self-inductance of the coil 3. Look at this. This is the self-inductance 2 Henrys and which will be represented with L11. And L22 means it is nothing but 6 Henrys. So we represent like this. L33 means we represent with as 4 Henrys. Like this. Similarly, L12 means here current enters the coil 1 at dot, whereas in the second coil current leaves the dot, so the sign of the mutual inductance 2 Henrys will be opposite to that of the self inductance, that is minus we get here. So we write the matrix like this. So L11 means this 2 Henrys, L12 means between this and this, that is 2 Henrys. Because the current enters the dot here and whereas current leaves the dot here and it comes under the dot rule 2, so the sign of the mutual inductance is minus. Then the L13, the mutual inductance between first coil and third coil, that is 5 Henrys, and the sign of this is positive because the current enters the dot in both the coils. Then L21, this is the second coil, this is the first coil. The mutual inductance between that is 2, and because current leaves the dot here whereas current enters the dot here, so the sign will be minus 2. Minus, so we will get minus 2. So then L22 means this is the self-inductance, so we put here 6 Henrys, and L23, there is no mutual coupling between second coil and third coil, so put 0. So then L31, the mutual inductance between coil 3 and coil 1, it is just like L13, so we get here again 5. Then L32, so this is the third coil, this is second coil, there is no mutual inductance, so put 0. Then L33 means self inductance, so put 4 here. So that completes the inductance matrix of this circuit. Let us take another problem. Write the inductance matrix for the following circuit. So here we have the different dots here, and the meaning of L11, L12, L13, L21, L22, L23, L31, L32, L33 will be same as that of the previous problem. And L11 means 2 henries, L12 means the mutual inductance between these two is 2 henries, and here the current enters the dot in both the cases, so it comes under the category called dot rule 1. So we put here plus. Then L13, here also current enters in both the coils at the dot, so the mutual inductance will get the only positive sign, so we get here 5. Then similarly L21 is nothing but L12, so we put here 2. Then L22 means it is nothing but self inductance of the coil 2, that is 6 henries. Then L23 means the mutual inductance between the second coil and third coil. There is no mutual inductance, so put 0 here. Then L31 means it is nothing but L13, that is 5. Then L32 means it is nothing but L23, that is mutual inductance between second coil and third coil is 0. So then L33 means the self inductance of the coil 3, that is 4 henries. So this completes the matrix equation for this circuit. So let us take another problem. Write the inductance matrix for the following circuit. So if you look at this, there are three coils. This is first, second, third. And if you look at this, here we have the dot here, and here we have the dot here, and here we have the dot here. In coil 1, current is leaving the dot. Similarly, in coil 3, current leaving the dot. And coil 2 is also current leaving the dot. And the notations for this also same as that of the previous case. L11, L12, L13, L21, L22, L23, L31, L32, L33. So L11 means it is the first coil self-inductance 2 henries. Similarly, L22 means it is the self-inductance of the second coil, that is 6. So we put here. Similarly, L33 means it is the self-inductance of the third coil, that is 4. Then coming to the L12, the mutual inductance between coil 1 and coil 2 is 2 henries. Current leaves in both the coils at a dot, so the sign of this will be same as that of the self-inductance, so we get here 2. And then L13 means the mutual inductance between coil 1 and coil 3 is 5. Because in both the cases current leaves the dot, so the sign of this will be positive as per the first law of dot rule. Then L21 is nothing but L12, so we repeat here. Then L22 already covered. Then L13, so there is no mutual coupling between 1. There is no mutual coupling between 2 and 3. This is 3, this is 2. There is no mutual coupling, so put 0. Then L31. So the mutual coupling between 3 and 1 is 2. L31 is 5. This is third coil. This is this first coil. The mutual coupling is 5 henries. And because the current is leaving the dots in both the cases, we put here plus sign. Then L32. This is the third coil. This is the second coil. There is no mutual coupling, so put 0. Then L33 means self-inductance. It is 4. So already covered. So let me take another problem. Write the inductance matrix for the following circuit. So look at this here. In the first coil, current leaves the dot, whereas in the third coil, current enters the dot, whereas in the second coil, current leaves the dot. As usual, the matrix for this is 3 coils, 3 into 3 matrix we get, that is L11, L12, L13, L21, L22, L23, L31, L32, L33. So L11 is nothing but the self-inductance of the coil 1, that is 2 henries. Then L21 is nothing but mutual inductance between coil 1 and 2, that is 2 henries, and the sign of this is same as that of the self inductance because the current leaves in coil 1 at dot. Similarly in coil 2 is also current leaves at dot like this. So it falls under dot rule 1 where the mutual inductance will get the same sign as that of the self inductance. So we put here plus 2. Then L13 means it is the mutual inductance between coil 1 and coil 3, that is 5 henries, and in coil 1 current leaves the dot, whereas in coil 3 current enters the dot, means it comes under the dot rule 2 where current enters the dot in one coil whereas the current leaves in the other coil, and the mutual inductance will get the negative sign as that of the self inductance or opposite to that of the self inductance. So here mutual inductance is 5 and self inductance for 4 or L11 is positive, so here we get minus. Then L32, there is no mutual inductance between coil 3 and coil 2, so it is 0. Then L33, there is self inductance 4 henries. Let us take another problem. Write the inductance matrix for the following circuit. So here we have the three coils, coil 1, coil 2, coil 3, and they have the self inductances 2 henries, 6 henries, 4 henries, and there is a mutual inductance between coil 1 and coil 2, that is 2 henries. Similarly, there is a mutual inductance between coil 1 and coil 3, that is 5 henries, and there is no mutual inductance between coil 2 and coil 3. So we get 3 into 3 matrix for this, and the notations for this also will be like this: L11, L12, L13, L21, L22, L23, L31, L32, L33. L11, L22, L33 are self inductances, whereas the others are mutual inductances. So let us fill the self inductances. That is L11 is nothing but 2 henries. L22 means self inductance of second coil, that is 6 henries. Then L33 means 4 henries. So put here like this. Then L12. The mutual inductance between coil 1 and coil 2 is 2 henries. Apply the dot rule now. In both the coils, current leaves the dot. See here, current flows through the coil, then leaves the dot. Similarly here, current flows through the coil, then leaves the dot. Means it comes under the category called the dot rule 1. So as per dot rule 1, the sign of the mutual inductance and the self inductance will be same. So we get here 2. Then L13, the mutual inductance between coil 1 and coil 3 is 5 henries, and applying the dot rule, if you look at this, it comes under the category called dot rule 2, that is current end leaves the dot in one coil. uh, Similarly in the other coil also current leaving the dot, means it comes under dot rule 2. So when the current leaves or enters the dots in both the coils, then the sign of the mutual inductance will be same as that of the self inductance. So we get 5 henries like this. Then 32, L32 means there is no mutual inductance, so put 0. L33 means 4 henries, so put 4 here. So let us take another problem. Write the inductance matrix for the following circuit, that is like this. There are three coils and three coils have the dots and also they have the mutual inductance. So this is there are three coils, so we get here 3 into 3 matrix. So the representation will be like this as usual, that is L11, L12, L13, L21, L22, L3, L23, L31, L32, L33. So let us first fill the self inductances. L11 means 2 and L22 means 6 and L33 means 4. 2, 6, 4. So L12 means it is the mutual inductance between coil 1 and coil 2, that is 2 henries. and apply the dot rule here. Here current leaves the dot. Similarly here also current leaves the dot. Current leaving the dots in both the cases or current entering the dots in both the coils comes under the category called dot rule 1, which says the mutual inductance sign and the self inductance sign will be same. So here we get plus 2. Then L13, the mutual inductance between coil 1 and coil 3 is 5 henries, and apply the dot rule here. So current leaves the dot here. Similarly here also current leaves the dot. So it comes under the category called dot rule 1, where the current leaving the dot in both the coils will get the same sign as that of the self inductance. So because the mutual inductance between the coil 3 and coil 1 is 5, so the sign will be 5 here, then plus 5. Then L32, there is a mutual inductance between coil 2 and 3, that is 3 henries, and the sign of this will be dictated by the dot rule. So in this case coil 3 current leaving the dot. Similarly in the coil 2 is also current leaving the dot. So it comes under the category called dot rule 1, where the current leaving both the coils, the mutual inductance will get as that of the self inductance. So we get here plus 3. So L44 means self inductance of the coil. L33 means the self inductance of the coil 3, that is nothing but 4 henries. So let me summarize once the numerical problems and the magnetic circuits. We have seen what are the dot rules, and we have seen what are the self inductances, and we have seen what is meant by mutual inductance, and we have seen how to apply the dot rules for the given coupled circuits. So here we have chosen the 3 coils with the different configurations.